So, welcome everybody to chapter 11, where we talk about the aggregate demand, and we would like to come up with a model which can explain the aggregate demand, like the demand side of our market, a little bit better. And in this chapter 11, we'll come up with the so-called IS-LM model. And I think in chapter 11, we are just rolling out the model. So we are spending a whole week only on the foundations so that we understand the different building blocks. And then next week, we are going to work with this IS-LM model. In this video, I'll only focus on the goods market. So in this part, I'll only talk about the IS curve, and I will cover the LM curve in a separate video. So the starting point is once more the Great Depression of the 1930s. This is something like the classical theory cannot explain why it is the case that for a longer time period, one economy can be stuck in a recession. That is impossible in the classical theory because the classical theory assumes that the goods prices will change, the nominal wage rate will adjust, and then the economy should get out of the recession. But the depression, like the worst year was in 1933. The unemployment rate was at the level of 25%, and the real GDP was 30% lower compared to 1929, the beginning of the Great Depression. One economist which tried to explain this Great Depression and the failure of the classical theory to explain this severe economic situation was Keynes. In 1936, he published his General Theory of Employment, Interest and Money, and he argues that low aggregate demand is responsible for low income and high unemployment. Therefore, we are going to focus a little bit more on aggregate demand in this chapter 11. In chapter 10, like our last chapter, it was the case that the aggregate demand was only explained by the quantity equation. And we were able to come up with two factors which influence aggregate demand. That is money supply and the velocity. And a negative demand shock can only be caused by a reduction in money supply or a reduction in velocity. The goal of this chapter is to identify those factors which shift the aggregate demand curve. And therefore, we want to get to know other factors others than money supply and the velocity which affect the aggregate demand. Furthermore, it was the case that in chapter 10, the government, or to be more precise, the central bank, only had one policy instrument, had only one policy tool to influence the economy, and that was monetary policy. So in case that a negative shock in the velocity decreased the demand in our economy, the central bank could increase money supply in order to counter this effect. In chapter 10, there was only one tool. This is different in chapter 11. In chapter 11, it is the case that the government can also use fiscal policy in order to stimulate demand in a recession. The government can increase government spending, or the government can decrease taxes. Hence, in chapter 11, it will be the case that the government and the central bank have more or less three different tools. The central bank can adjust money supply, and the government can adjust government spending or the taxes. The IS-LM model is the leading interpretation of Keynes' theory. But the IS-LM model was not developed by Keynes himself, but by Hicks, like in the year 1937. So Keynes published his book in 1936, and Hicks related the IS-LM model to the ideas of Keynes. The goal of this IS-LM model is to explain GDP for a given price level. So the price level will not play this central role anymore because we assume that the price level is given. We want to focus on GDP. We want to focus on the factors which influence the demand and hence in the end GDP. So we have two different interpretations of the IS-LM model. One interpretation is that we want to answer the question, what causes income to change in the short run when prices are fixed? And the other idea is that we want to find out what influences aggregate demand. We want to develop a model which is a little bit richer compared to only focusing on the quantity equation. IS-LM. What do these abbreviations stand for? IS is an abbreviation for investment and savings, and it is related to our goods market equilibrium condition because in the closed economy, the good market equilibrium condition is, or like one representation of the good market equilibrium condition is, that investment has to be equal to public savings. What does LM stand for? L is an abbreviation for liquidity demand, and M is an abbreviation for money supply. So, like we also want to look at the money market and want to derive a money market equilibrium where money supply is equal to liquidity demand. And then we are combining IS and LM to one model in order to explain GDP and the interest rate level simultaneously. So with the IS-LM model, it is the case that we can determine on the goods market the GDP level, and on the money market we can determine the interest rate level. But we are not analyzing these two markets in isolation, we are analyzing these markets simultaneously because of the fact that there is an interdependency between both markets. A change in GDP will affect money demand and therefore the money market equilibrium, and a change in the interest rate will affect the demand for investment goods, will therefore influence the demand for goods and hence the GDP level. And therefore we have an interdependency between the goods market and the money market, and we have to analyze both markets simultaneously. That's it with respect to the introductory remarks. Let's start with the chapter which derives the IS curve. This chapter starts with some definitions with respect to actual expenditure, planned expenditure, and unplanned inventories. Let's have a look at these definitions and how the different elements stand to each other. Actual expenditure, this is actual GDP, our Y variable. This is the amount households, firms, and the government spend on goods and services. And planned expenditure, this is the amount the households, firms, and the government would like to spend on goods and services. What is the difference? The difference between actual expenditure, Y, and planned expenditure, PE, is unplanned investment or unplanned inventories. What is that all about? We said the difference between actual expenditure and planned expenditure is equal to unplanned inventories. Firms can have unplanned inventories when their sales do not meet their expectations. So when the companies are producing more compared to what is planned by the different agents, then it is a case that supply is larger than demand, and the companies have produced something, and the companies have to increase inventories, but this is not planned by the companies. This is a kind of surprise. So in case that Y is larger than PE, then I unplanned is larger than 0, and the companies have to build up inventories, they have to build up stocks, and since this is unplanned, which implies that this is unwanted, then companies will reduce production in the next period. Companies are adjusting GDP so that GDP decreases, and hence also the unplanned inventories increase. So of course, one equilibrium condition will be that unplanned inventories is equal to 0. And in this situation, it has to be the case that actual expenditure has to match planned expenditure. Planned expenditure is equal to planned consumption, planned investment, and planned government spending. The consumption function is once more given by this relationship: autonomous component of consumption plus marginal propensity to spend times the disposable income. The investment is exogenous, therefore we have a bar above the I variable, and government expenditure and taxes are also exogenous. Now we are combining all elements, so we are inserting this T bar in the consumption function, we are inserting I bar into this relationship and also government spending into this relationship. In the end, equation 5, the right-hand side, into equation 4. So when we combine all functions, then we get this equation number 7. So that planned investment is equal to our planned consumption, our planned investment, and planned government spending. In the following, we would like to graph this relationship, this function, in one figure where we put planned expenditure on the vertical axis and income and output on the horizontal axis. So planned expenditure on the vertical axis and Y on the right-hand side. It is a case that we have here some autonomous components. They are positive, and therefore the curve starts at this point. This planned expenditure curve intersects with the vertical axis at a positive range because of the fact that we have all these positive elements here in the planned investment function. Then we have to think about the slope. The slope of this curve is given by the marginal propensity to consume. In case that income increases by 1 unit, the planned expenditure increases by C1, like the marginal propensity to consume. In case that we assume that marginal propensity to consume is 0.6, for example, then when income increases by $1, consumption increases by 60 cents, and 40 cents will be saved by the private households. So when income increases by 1 unit, consumption does not increase by 1 unit, but only by C1, and this gives the positive slope of this curve. In the next step, I also would like to visualize the equilibrium condition, and the equilibrium condition is that realized output is equal to planned output, so that Y is equal to PE. And this relationship can be visualized by a 45-degree line which runs through the origin, because along this line, this condition is fulfilled, that GDP is equal to planned investment. So in case that the economy is in this point A, then we can find the equilibrium income level here on the horizontal axis. In this point, actual expenditure is equal to planned expenditure, so that unplanned inventories are equal to 0. So we can use this graph in order to find the equilibrium income level. This relationship here, this crossing, has a special name. It's called the Keynesian cross. So the Keynesian cross is related to this diagram where we have planned expenditure on the vertical axis and output and income on the horizontal axis. This is the Keynesian cross. Of course, we can also look at situation where the economy is not in an equilibrium. Let's talk about the adjustment process and assume that we are in the situation Y1 where produced output is equal to Y1, but planned expenditure is only at the level of PE1. So it is the case that unplanned inventory is positive. The companies, they are building stocks, which is unwanted on the company side, and therefore it will be the case that in the next period the companies will start to produce less. They will only produce that amount of output which was also demanded in the last period, and hence we are moving into the direction of the equilibrium. At this level of output is the case that the planned expenditure is even lower, and hence this adjustment process will take some time over some periods, which is indicated here by the small arrows that it takes time, it needs several steps until we reach the equilibrium. In case that we start in scenario 2, where the GDP level is on the level Y2, it is the case that planned investment is larger than output. The different agents, like the households and the companies and the government, is demanding more than is produced by the companies, and therefore the companies are decreasing stocks. The companies are decreasing their inventories. And that is unplanned and therefore unwanted, and therefore the companies will start to produce more, and we are moving into the direction of the equilibrium. Hence, we have talked here about the adjustment process. What happens if we are not starting in one equilibrium? What is the adjustment process? Why is this equilibrium stable? In the next graph, we are analyzing what happens if the government increases government spending. The initial equilibrium, this is point A. The economy is in an equilibrium, but then the government increases government spending. The government wants to spend more, and therefore planned expenditure increases. The planned expenditure curve shifts upwards so that now the red planned expenditure curve is valid, and hence the new equilibrium level is given by the situation B. The new equilibrium level is Y2. We can see here that an increase in government spending leads to an increase in the equilibrium level of income. So this is new here. On this slide, we learned something new because of the fact that here in chapter 11, the government has also the tool of government spending to increase demand and thereby increase output. This policy tool was not available in chapter 10 because in chapter 10 we only focused on money supply. But here it is the case that the government can affect demand and thereby also affect supply by increasing government spending. One big question in macroeconomics is how large is the effect of income? Is it the case when the government increases government spending that this will only increase the GDP level by the same amount? Or is it the case that the income effect is larger than the initial impulse? In case that the effect on GDP is larger than the initial impulse from the government, then a positive multiplier is working and the multiplier is larger than 1. In the following, I would like to derive this multiplier and check by how much income will increase in case that the government increases government spending by 1 unit. In case that you want to look at the textbook, please have a look at page number 312. There, this exercise is performed in footnote number 3. We start with the function for planned income. Planned income is equal to consumption, investment, and government spending. Now we also consider the equilibrium condition. In equilibrium, output Y has to be equal to planned expenditure. Therefore, we can insert Y here on the left-hand side of this equation. In case that we want to compute the income multiplier, we have to differentiate equation 9, which is called like the total differential, and we have to write a D in front of each variable. And here it's very important to remember that C1 is not a variable, but a parameter, and therefore we are assuming that this parameter is constant, and we don't have to differentiate with respect to the parameter C1. We only differentiate with respect to all variables. So we write a D in front of each variable, a D in front of the left-hand side variable, and also a D in front of all right-hand side variables. We have computed the differential. Now we have to check the different components. Like the autonomous component of consumption is constant. C0 is constant, it does not change. Therefore, the change in the autonomous component of consumption is 0. So DC0 is equal to 0. Investment is constant. Investment does not change. Therefore, the change in investment is equal to 0. DI is equal to 0. Furthermore, it is the case that taxes are constant. They do not change, and therefore the change in taxes is equal to 0. In this upper equation, I have marked all those components which are equal to 0. And when you set these components equal to 0, you are left with dy is equal to C1 dy. And then here we have the change in government spending. Because of the fact that the government increases government spending by 1 unit, dg takes the value of 1 unit. Now we have to solve this relationship for dy. In the first step, we can put C1 on the other hand side of the equation, like C1 dy on the other hand side of the equation, pops up with a negative sign here. Then we can write dy out of brackets, so we get 1 minus C1 times dy. And in this next step, we divide equation 11 by 1 minus C1, and we get to this relationship here. We have isolated dy on one hand side of the equation. In the next step, we can divide by dg, and then we have computed the income multiplier of a fiscal expansion in form of an increase in government spending. This relationship tells you how much income changes in case that government spending changes by 1 unit. It's equal to this fraction, and this fraction is larger than 0, so this relationship is positive. Why is this fraction positive? It's positive because C1 is smaller than 1. C1 is positive, but smaller than 1. Therefore, the denominator is positive and the whole fraction is positive. How should we interpret this positive sign? This positive sign has to be interpreted in the following way. In case that government spending increases, it will be the case that also income increases. There is a positive relationship between these two macroeconomic variables. How large is this relationship? Let's plug in a numerical value for the marginal propensity to consume. Let's assume that C1 is equal to 0.6. Then we get here 1 over 1 minus C1. It's equal to 1 over 1 minus 0.6 is equal to 1 over 0.4, which is equal to 2.5. So now when we know the value for C1, then we can compute the income multiplier. We can generate a numerical value for this income multiplier, and it's a positive 2.1. This has to be interpreted in the following way. When the government increases government spending by 1 unit, then income increases by 2.5 units. Great. So, we performed in the first step a graphical analysis. What happens if the government increases government spending? It leads to a higher level of GDP. And then we quantified this effect in a first step in a relatively formal way. But then we also used the numerical example to exactly point out how large is this income multiplier of an increase in government spending. In the next section of this chapter, we ask the question, what happens if the government decreases taxes? I underlined decrease here. This is very important to not mix it up. Previously, we talked about a fiscal policy in the form of an increase in government spending. And here we talk about an expansionary fiscal policy in a form of a decrease in taxes. We discussed this stuff in the so-called Keynesian cross, the diagram you're already familiar with. When it is the case that the government decreases taxes, the disposable income increases, so that consumption increases. The demand for consumption goods increases, and this shifts the planned expenditure curve upwards. The blue line shifts upwards, the red line is valid, and hence we get here the information that also when the government uses a decrease in taxes, income will increase. The big question here is, will it be also the case that income increases by 2.5 units, or is the multiplier different? So we have to compute the income multiplier of a change in taxes. I think that it is important to emphasize here that in a first step, we have to derive the income multiplier of an increase in taxes. And then when it comes to the interpretation, then we can change something. When you want to have a look at the textbook, it is the case that this is derived on page number 313 in footnote number 4. We once more start with the total differential, but now it is the case that the government changes the tax rate, but keeps government spending constant, so that the change in government spending is equal to 0. Like the red elements are once more equal to 0, and hence we end up with equation number 16. dy is equal to C1 dy minus C1 dt. Now we once more have to solve this relationship for dy. So in the first step we put C1 dy on the other hand side of the equation, pops up here with a negative sign. In the next step, we can write dy out of brackets, and we get 1 minus C1 in brackets times dy, which is given here in equation 17. Now we are dividing equation 17 by 1 minus C1, and we get to this relationship here. 1 minus C1 on the other hand side is equal to dy equal to minus C1. This minus sign stems from this minus sign here. So we find this minus sign also there. And when we now put dt on the other hand side of the equation, then it is a case that we have derived the income multiplier of an increase in taxes in this relationship. The numerator is positive, the denominator is positive, but we have a negative sign in front of this fraction, so that the whole expression is negative. This negative sign has to be interpreted in the following way. When the government increases taxes, then income decreases. There is a negative relationship between these two macroeconomic variables. When the government increases taxes, then GDP decreases. How large is this effect? We have to plug in the numbers we have. C1 is equal to 0.6, so we get to minus 0.6 over 1 minus 0.6, or minus 0.6 over 0.4, or minus 1.5. So the income multiplier of an increase in taxes takes the value of minus 1.5, and this has to be interpreted in the following way. When the government increases taxes by 1 unit, income decreases by 1.5 units. And now we can turn this argumentation around. What happens if the government decreases taxes by 1 unit? When the government decreases taxes by 1 unit, then income will increase by 1.5 units. So this is the point where we are switching once more our line of argumentation. Let's talk a little bit about the empirical effects and real macroeconomic policy, like macroeconomic policy in the real world. And there are several case studies in the book. I would like to talk about the case study which talks about cutting taxes to stimulate the economy, the Kennedy and the Bush tax cuts. And here it is mentioned that there are two effects in case that the government decreases the taxes. One effect is called the supply effect, and this line of argumentation is put forward by supply-siders. They argue the cuts in income taxes increases the incentive to work. We have a larger labor force, so more labor and therefore a higher output. So the supply-siders argue a decrease in income tax is important, and a decrease in income tax can stimulate the economy, but via the supply side. Labor supply is up and therefore output is up. We are looking here at the supply side. The demand-siders, they argue differently. They argue in the following way, that a decrease in income tax leads to a higher disposable income, and this will stimulate consumption and it will increase the demand. So the two lines of argumentation are completely different. Nevertheless, both lines of argumentations, they emphasize that a cut in taxes is a good thing because of the fact that GDP will increase. Until now, we have worked in the diagram where we have planned expenditure and output on one of the two axes. So we worked in the so-called Keynesian cross. And this will change in the next few slides because of the fact that we want to derive the IS curve. We want to derive the IS curve on the basis of the knowledge you gained so far. We have to adjust our assumptions a little bit, and we are adjusting our assumptions with respect to the investment function. Until now, we always assumed that investment is exogenous. But this will change now, and here we are assuming that the investment function depends on the interest rate in the following way, that in case that the interest rate increases, then investment will decrease, and in case that the interest rate decreases, investment will increase. Why is that? Why is there a negative relationship between the interest rate and the investment function? This is because when the interest rate decreases, it's more attractive to invest in the real economy because of the fact that now it is easier to borrow money. The interest rate is lower, it's easier to borrow funds, and therefore it is easier to invest. A lower interest rate leads to more investment. When the interest rate decreases, then it is the case that more investment takes place. The demand for investment goods increases so that planned investment is up. What happens if the interest rate increases? When the interest rate increases, it's more expensive to borrow money, it's more expensive to borrow funds, and therefore less investment will take place in our economy. The companies will adjust their plans to invest. Planned investment will decrease. So an increase in the interest rate leads to lower planned investment. Let's have a look at these three graphs and start in panel A. We are in the blue scenario. This is the initial scenario. And we want to find out what happens if the interest rate increases. You are familiar already with this chart because it shows you the investment function, like the negative relationship between the interest rate and investment. In case that the interest rate increases, it's a case that investment decreases. The companies are planning less investment, and therefore planned expenditure decreases. The blue line shifts downwards, and therefore we get a new equilibrium here. Initially, the GDP level was at this level here, but now we get like a lower GDP level in this red point. And now we want to draw our first IS curve. And we draw this IS curve in an interest rate income diagram. The initial point was a blue point here at this level of the interest rate. This is the corresponding level of GDP, which stems from the upper part of the diagram. But in the red scenario, where the interest rate increases, the corresponding GDP level is lower, and therefore we have to use this red dot here in this right diagram. From this considerations here, we get the information that the IS curve is downward sloping in an interest rate income diagram, so we have derived one characteristic of the IS curve. We know now that the IS curve is downward sloping. This is the first characteristic. The second characteristic, which is derived in this chapter, is what happens to our IS curve in case that the government increases government spending. What happens if the government increases government spending? The planned expenditure curve shifts upwards, and we get to a higher level of demand. The second characteristic I would like to talk about is that an increase in government spending shifts the IS curve to the right. Why is that? We start in the upper diagram in the blue Keynesian cross. The government increases government spending so that planned expenditure increases. The blue expenditure curve shifts upwards and the red expenditure curve is valid. We can see here that this leads to an increase in GDP. So an increase in government spending leads to an increase in GDP and shifts the IS curve to the right. At a given interest rate level, there is a higher demand, there is a higher level of GDP, and therefore an increase in government spending shifts the IS curve to the right. This is the second characteristic. Like the first characteristic was the IS curve is downward sloping, and the second characteristic, an increase in government spending shifts the IS curve to the right. Let's sum up the first part of this chapter, which deals with the task of deriving the IS curve. The IS curve shows combinations of the interest rate and income that are consistent with an equilibrium in the goods market. So all the different combinations of the interest rate and the GDP level, which leads to an equilibrium in the goods market, they create this IS curve. And we are inserting the IS curve in an interest rate income diagram. One IS curve is drawn for a given amount of government spending and a given amount of taxes. A change in fiscal policy which raises the demand for goods shifts the IS curve to the right. So in case that the government increases government spending or decreases taxes, this shifts the IS curve to the right. And changes in fiscal policy which reduce the demand for goods shift the IS curve to the left. So when the government decreases government spending or when the government increases the taxes, this will shift the IS curve to the left. Like this is the first half of this chapter. I know that this is very demanding because like a lot of different aspects play a role. Therefore, I would like to give you the chance to digest, take a few minutes and reflect what was going on, go back to the textbook and study a little bit what was going on in the first part of this chapter where we derive the IS curve. And this is only the first part of this chapter because we want to derive the IS-LM model. What is missing right now is of course completely the money part, the LM part. Thank you very much. Have a nice day. Bye-bye.